Have you ever seen something that is one size fit for all? Or something that can be used to hold any kind of item, like a bag or something? In this chapter, we're going to talk about Java generics. We'll explore the topics like wrapper classes, generic methods, generic classes, bounded type parameters and methods, type parameters, wildcards, generic interfaces, and related topics.
In this chapter, we're going to talk about generics, and especially in this video, we're going to talk about wrapper classes in Java. For that, I would like you to open this file, primitive wrappers, under the project generics. In here, I have the array defined, and this is a string array with the size of 2. That means we can't insert more than 2 elements. But when we try to insert a third element, we're going to get array index out of bounds exception. Let me run the program. There it is. Let's comment this out. So that's clearly a problem. We want an array that expands as and when we add new elements. And that's where this array list comes into picture. We'll talk more on array list, the syntax of it, etc. when we talk about collections. But for now, think of array list as an array that has a variable size. That means as and when we add new elements, the size of the array is going to expand by itself. But we have a limitation here. As per design, the array list is going to accept only objects. We can't pass any primitive type in here, like int or float, etc. But there could be cases where we want to add integers as elements to this array list. And we cannot use array because the size is fixed. That's where the wrapper classes will come into picture. In here, I have the primitive type int. We can get the object representation of this primitive type int by using the class integer, whose parent is the number class. And we're going to create a new instance of that class by passing an integer value as an argument to this constructor. By doing so, this is going to be as good as the primitive int, but it's an object. And now we can gladly pass an object to constructs like this. So for example, we can say integer instead of the string. And of course, we need to keep adding integers, not the string in here, when we change the data type in here. Let's undo those changes. Again, we'll talk about array list at a later point of time. Now if you see, the class integer is kind of acting like a wrapper for the primitive int, which means internally this statement is going to use the primitive int, but for us we're actually dealing with the integer object. Hope that makes sense. This is called boxing because we're kind of taking the primitive int and we're boxing it or wrapping it and making it look like an object. Now in this statement, we're finding the addition or the sum of two integers, but one is primitive int and the other is integer. The plus operator is going to accept only the primitive data types. So in here, Java automatically does unboxing for us. Essentially what this means is the object is again converted back to primitive int just for this calculation to happen, and this is called unboxing. Also, instead of creating a new object, you can directly assign a value and is internally going to create an object for us and make this reference type point to that object. Similarly, we have the primitive type double. The object representation of primitive type double is again double, but with a capital letter D. And now D1 is going to act like the object representation of double. Now we can clearly send this object to constructs like array list. Similarly, we have other wrapper classes, byte, float, short, long, and they're all child classes of the number class. Likewise, we also have the character class, which you can use to have an object representation of char data type. And another advantage of using the wrapper classes is you can make use of the methods inside these classes that are predefined. For example, I can say C dot, and you got a lot of methods, constants, etc. that you can make use of. You can explore the methods by reading the description in here. So that's it for this video. With this in mind, we're good to go with understanding what are generics in Java. In this video, we're going to talk about generic methods. First of all, let me demonstrate you the problem that we have without using the generics. In here, I have defined three arrays. One is int array, the other is double array, and lastly we have the char array. I also have three methods accepting all these three different types of arrays, and they all have exact same code inside them. So all these three methods are having exact same name as well as the code, except they differ in terms of type of arguments that they're receiving. Now tomorrow, if I decide to add another array with a different data type, maybe a string or your own object, then I'm going to copy this method once again and specify the data type in here or whatever. This is clearly a problem. Why should we create so much of code when doing the exact same thing inside all these methods? That's where the generic methods will come into picture. So with generic methods, I can get rid of all these methods in here and keep only one. And I'm going to do something to this method that will enable this method to receive any kind of parameter that's going to come in as an argument. So for that, I'm going to make use of something called a type parameter. You need to specify the type parameter right before the return statement, and it's going to reside inside the Wrangler brace. And in here, you can literally give any kind of capital letter. But since this is called the type parameter, as a good naming convention, we developers always use capital T. And once you defined the type parameter, you can literally replace all these specific types to this generic type. Now this letter T is a generic type. This could be int, this could be string, this could be your own object or whatever. Now whatever we have here is nothing but a generic method, but generic only works with objects, not primitive types. So we need to convert all these primitive types into objects. How do we do that? Any guess? We're going to make use of the wrapper classes that we had talked about in our previous video. So this is going to be an integer, and this is going to be double, and this is going to be a character array. Now guess what? Our program will run smoothly. Of course, since we have println, every character will print in a new line. And let's also have a sysout statement in here just to make sure that there is a new line character after printing all the elements in the array. Now let's see. This looks a lot cleaner. Anyway, the point I want to make here is we have shrinked all those methods into one single method, and that has reduced the lines of code dramatically. And let's say I'm going to create another array. This is string array, and let's do that. String, and I'm going to pass in some string elements into this array, apple or whatever, say banana. Let's get rid of the rest of these elements, which are character elements. String array, and you can gladly call this method by passing this argument. Everything works great. But do keep in mind that whatever the code that you have inside the generic method, make sure it works with any type of argument that is expected to enter inside this method. For example, say I'm writing an instruction that is specific to string object. Let's say string str equals array of, I'm going to get the first element from that array. It's going to be string, and I'm trying to convert this into a string object like so. Now if we have any kind of an argument that cannot be converted into a string object, for example an integer object, both integer and string are incompatible types if you look at the class hierarchy of them, and that's going to throw a runtime exception. Let's try to run the program. There it is, class cast exception. So make sure you have the code that matches with any kind of argument that is expected inside that method. Let's get rid of this statement and save the file. You can even return a generic type. So instead of having void as a return type, you can just have this generic type t. And now we can return the generic type from this method. Just showing an example, but you can play around with it. Let's undo those changes. Oh, let me just show it to you. I'm going to say t obj equals, say I'm going to have a string apple is a fruit or whatever, and I had to make sure that I convert or typecast this into that generic type. Only then will I be able to return that object. Let's comment this line and run the program. Alright, we didn't use the sysout statement. Sysout. Now we should see this string printed once. Let's save the file and run the program. Great. Let's undo all those changes. Just wanted to show you that you can return the generic type. So that's it on generic methods. We'll talk more on generic method pretty soon with a good example. Also, one last thing. In this case, we just used one type parameter. We can have more than one, and we'll see an example of it pretty soon. See you in my next video.
In this video, we're going to talk about generic classes. For the purpose of this example, I have created 3 classes. In integer class.java, I have a variable which is of type integer, and we have a setter and a getter to set the value of this variable and to get the value of this variable. Similarly, we have double class.java, and in here we're doing exact same thing, setter and getter, but the type of data is double. Similarly, we have the string class with a string variable. So basically the intent of all these 3 classes is same, except they differ in terms of the type of data. And in our generic class example, I've created an object of all these 3 classes, and I'm calling setters and getters. For integer class, I've set the value as 10, and when I do get var, it's going to return me the integer object, and that will enable me to call the method that was specific to integer object. So I'm able to call this method double value, which is of integer class method. Similarly, when we get the double object in here, I'm calling a method that is specific to double. Same is the case with the string object. I'm trying to get the char at index 1. Now tomorrow, if I wanted to add one more class with a different data type, I need to create another class just as these 3. That's an additional overhead. How can we get rid of it? One solution is to
create a single class which will have a variable which is of type object. And since object is the ultimate parent of every class in Java, integer, double, string or no exception, they're all child classes of object. So if I create an instance of this class, it's going to accept any kind of data type as long as it is object. So let's change that. So instead of using integer class, I'm going to replace everything with this object class. And now we can get rid of all these three classes. We can delete them, but for your reference, I'm going to leave them there. But clearly we have one problem here. In here, we're trying to access a method that is specific to the integer class. And in here, the double class, and in here, the string class. So what can we do? We need to typecast this. Let's do that. Let's typecast this to integer. Let's organize the parentheses. And similarly, we need to typecast this to double and this to string, which will definitely frustrate any programmer in the world. Another problem is, let's comment this code. I can literally set any kind of value in here. I can even pass string. Now this is going to pose a runtime exception because we cannot cast a string to an integer. Class cast exception. So this is clearly a problem. So we cannot use the object class. What is the solution? Generic class is the answer. Let me copy this code from here and paste it over here. And right after the class name, we're going to have the type parameter. And of course, it's going to go in angular braces. As a good naming convention, let's use capital letter T. And wherever you're using specific data type, we're going to replace it with this generic type. So I'll do Control F, replace it with capital T, and I want to replace it everywhere I see it in this class. Replace all. Now guess what? In our example, we can now use the generic class like so, but we can send the type argument. In this case, it's integer. You have to have the same thing in here. Of course, this class is going to be the generic class. And now we have a compile time error. Compile time errors are less expensive compared to runtime errors. So in here, we're forced to provide only integer type as an argument. And another advantage is we no longer need to typecast this to integer because Java knows it already. Java is aware that the only parameter that we can send is of type integer. Now we can gladly uncomment these lines of code, and of course you're going to use the generic class construct here. This is going to be double. Let's copy this, store here. It's going to be string. Pretty well and good. Now you can go ahead and feel free to delete all these files and use only the generic class. Now tomorrow, if I wanted to add the similar functionality for another data type, I don't have to create another class. I can simply use the same generic class. One of the most confused terms while learning the generics in Java is the difference between type parameter and the type argument. Whatever we have here is a parameter, and whatever we're sending from here is an argument. So this is going to be a type argument, and this is the type parameter. Hope that makes sense. Lastly, let me just point out that whatever the methods that you're going to write in here, again, they have to be type safe. Just as our previous example when we talked about the generic methods, we cannot have a code that is not compatible with the type of arguments expected in that method. Alright, I guess it makes a lot of sense to use generic classes at times. Definitely it will help developers write a clean code. Alright, see you in my next video. In this video we're going to talk about bounded type methods and bounded type classes. But before that, I guess it's worth mentioning that we had already used generic classes in our first example. Remember we talked about the array list? In that we had sent string as a type argument, which means we cannot add any other element that is not of type string. So we cannot add something like integer or something that will give a compile time error. And when reading the value, we don't have to explicitly typecast it because Java already knows the kind of elements we are storing. In this case, it's string. Alright, going back, let's talk about the bounded type methods. Sometimes you might want to restrict the kind of argument that the method will receive. For example, in here, we're performing some kind of a mathematical operation. We're converting whatever is being sent as an argument to an int value, and we're trying to multiply it by 100. So in this case, we don't want string or a character to come as an argument. Whatever the type of data is going to be entering inside this method, it has to be a child class of the number class. If you remember, I said all our wrapper classes like integer, double, byte, float, short, long, they're all child classes of the number class, and they basically deal with numbers. And since we're doing a mathematical operation here, we want to accept only the objects of classes that are child class of the number class. And the way we specify that is like so. Earlier we had this, but now if I say extends number, this method is going to accept the objects of the child class of the number class. So in here, I've created multiple objects belong to different types. When I pass integer, double, or byte, there's no problem. But when you try to pass string, we're going to get a compile time error. Let's undo that. Similarly, when you try to pass a character, we're going to have a compile time error. Same is the case with bounded type classes. Let's say this class is meant for dealing with integers or numbers, let's say. Now we don't want to have any type parameter that is not a number. So we put that restriction in exact same fashion. And by doing so, we're no longer permitted to send string as a type argument that will give a compile time error. Hope that makes sense. See you in my next video. We had talked about generic methods and generic classes. Now let's put these things together. In our generic class.java, we had used one single type parameter. However, at times, we might want to use more than one type parameter. And that's exactly what we did here in keyValuePair.java. I have a couple of generic variables and with their getters and setters, along with a constructor to set the values for both these variables. Now both k and v can be of any type. In this example, we are making use of that class to create objects. So I have instantiated this class, but we need to send the type arguments. In this case, I'm sending integer and string. So same goes in here, integer and string. By the way, we can have these two defined in here, or you can just simply ignore it. Both are equivalent. Moving on. So I've created three objects of that class. And since this looks like a key and a value pair, as a good naming convention, I had used uppercase K for key and uppercase V for value. This makes more sense when we talk about hash map in our collections chapter. Also, we have a generic method that's going to take a couple of generic variables, and since we're expecting a couple of generic variables, we need to define the same in here. within the angular braces. I'm sending two such objects, the objects of key value pair, and I'm comparing both. I'm checking to see if they both are similar. In this case, these two key value pairs are exactly same. And when we compare both these objects, we should get the result as true. And in here I'm comparing P1 and P3, which are not identical. Then this should result in false. Let's run the program. Pretty well and good. See you in my next video. In this video, we're going to talk about wildcards in Java generics. First of all, I think it's not really worth knowing about wildcards because it does exactly what type parameters does with only one noticeable difference. So if whatever we had talked about so far sounds confusing to you, then you can simply skip this video and go ahead with my other videos. That being said, I'm going to talk about the wildcards anyway, just for the sake of completeness. So what are wildcards? Before we understand what it is, take a look at this example. In this class, I have one method and it's going to accept object as a parameter. Now since string and integer are subclasses of the object class, we can also pass the string and integer objects to this method, and that's exactly what we did here, and it accepts. But let's say we're sending a list. Let me uncomment the code that I've commented here. Let's get rid of this. Let's save the file. In here, I've created three lists. One is of object, the other is of string, and the other is of integer. And I've added some elements into these lists. But the point here is this method in here is going to accept an array list of objects. So obviously, since this is an array list of objects, we can pass this to this method without any problem. But if I try to pass this, which is a list of string objects, to this method, will it accept it? Can you make a guess? The answer is no. Although string is a subclass object, Java does not really typecast this entire string list into a list of objects. In other words, Java can typecast a string or an integer to an object implicitly, but it cannot really convert list of string or list of integers into list of objects. These two are two different things. Hope that's clear. And so if I uncomment these two lines of code, it's going to show a compile time error. That's going to say the method display list, array list of objects in the type wildcards, the name of this class, is not applicable for arguments array list of string. And that's very obvious, as I've explained. So what can I do to this method in here so that it's going to accept any type of argument? Obviously, we're going to make use of generics. So we're going to have a type parameter in here, and we're going to give that generic parameter type in here. And this is going to solve the problem. But in here, since the type parameter is appearing only once in this list of parameters, we can simply get rid of this and instead use a question mark sign. And guess what? This is nothing but a wildcard. The only difference between having to use the type parameter versus the wildcard is that the wildcard makes this method look more obvious that it can accept any kind of parameter. Syntactically, it looks more appealing. So basically, in other words, the question mark or the wildcard means an unknown type. That means compiler does not know what type of argument this method is going to receive during the compile time. It knows it when we run the program. And as I said, we can still use type parameters. This just looks visually more appealing. But if you have this method accepting more than one argument, both are of generic type, then you would better off go with type parameter rather than using a wildcard. The reason is, let me show you what I mean. Say you have another argument in here, let's call it D or whatever, and comment the code. In here you can send list of objects as well as the list of strings. These two arguments in here may not be of same type, so that will bring some additional complexity in handling those parameters inside your method. So in this case, it would make more sense to use a type parameter like t, and then you're going to tell it over here. So that way you will get the error during the compile time itself. So either you should have both these arguments, a list of objects or a list of string, but not both. So you can send like this. Now this is going to be acceptable. Hope that makes sense. Let's undo those changes. And I was mentioning that there is one noticeable difference between a wildcard and a type parameter, is that in type parameter we can limit the type of argument that's going to come in using the extends keyword. For example, if I say extends number, so we cannot send object or a string because we're accepting only the classes that are extending number. This is possible even with the wildcards, but there's one thing which is possible with wildcards and is not possible with type parameters, is you can use super keyword, or let's say it integer. Now guess what? Since object is a superclass of integer, we can pass either object, either list of objects or list of integers, but not list of strings, and that's why we have a compile time error here. So that's it on wildcards. We don't really need to know a tad bit more than what I've just explained. So see you in my next video. You can also define generic variables in interfaces. A good example of that would be the ArrayList class, which is going to implement an interface called the list. Let's go into the source code of ArrayList. Again, I'm going to make use of the grepcode.com for this purpose. We have the source code of ArrayList, and as you can see, it's going to implement the list interface, which I have it here. The list interface has defined a type parameter, which is a generic type, obviously. And if you see, this generic parameter is used in some of these methods. For example, we have a toArray method, and it's going to accept that generic type and is actually returning the generic type. And since the ArrayList implemented this interface, it has to provide the implementation for this method. And if you scroll down, you should see it. Let's search it. Here it is. So it had used the same method which is defined in the interface and has provided the implementation. Anyway, all this would make more sense when we talk about the collections framework, which we will pretty soon. But I just wanted to tell you that generic variables were extensively used in interfaces. Hope that makes sense. See you later.
I hope you enjoyed this tutorial. Please like and subscribe. The link to the next part of this course is in the description below. Also, if you want to learn Java with practice, with quizzes, assignments, coding puzzles, and interview questions, I cannot do that on YouTube. So you need to take this course on my own website. The link is in the description below. I'll see you in the next part of this course.